All right, so now we are on the last and final question of the packet, the monster packet. So we see that we have got case 1 and case 2. In case 1, we only have one mass, and then we have this kind of force that's pulling down. And then in this case, we've got two masses, and they're going in the same direction, but it's only because of this mass right here. And it's not because of there's something pulling it. And so we first want to calculate the acceleration of the 10 kilogram block in case 1. So let's do that. So to do that, let's draw ourselves a free body diagram. So we have got this block right here. And this block, of course, has got normal force, our mg, our weight, this frictional force, and this tension T. And we see that this tension T right here is going to be the same as this tension T right here. So this tension is the same kind of throughout. And we're not going to add our, we're not going to have to cancel these tensions out. So let's say we've got the sum of the forces in the x direction is going to equal MA, because there's only one M here. So see how there's only one M, so all you have to do is just put MA equals, and we see that the tension is going the same direction as that acceleration, so you're going to say T minus F. But wait a minute, F is a little more complicated than just plain old F, right? F, this friction is going to be mu times normal. And we see that the forces in the y direction are in balance, so this normal force will equal the mg, right? To prove that to you, let's go ahead and say sum of the forces in the y direction equals 0, right? Because we're not accelerating the y, we're only accelerating the x, equals your normal minus your mg. Add your mg to both sides, so that normal equals mg. All right, so basically friction is mu times normal, which is also mu times mg, okay? So we're trying to figure out what is this acceleration, so let's divide this m by both sides. So we end up with A equals tension minus this frictional force, which we just found, which is mu mg divided by this m. So now let's plug everything all in. And so we get tension, which is going to be that force of that 50 newtons pulling down. 50 minus 0.2 times this 10 of this mass, 10 times our gravity, which is 10, all divided by 10. So really, this is just going to be 5 minus 2, which ends up just giving us 3 meters per second squared. All right, so that's part A. Part B are just a couple of free body diagrams. So looking at this case number 2 this time, and so for case number 2, again, it's going to kind of look very similar to case number 1, but this time we have this added mass to it. So looking at the 10 kilogram block, we've got our normal again, we've got our M, but this time, because we have two masses, let's say M1G, and we've got this T right there, we've got that frictional force, which is the same frictional force as over here, because our mu stays the same, our M stays the same, and our G stays the same. So this frictional force will stay the same as well. Then right here, we've got this tension, and then we've got this M2G. So that's how you're going to draw your free body diagram. So what we want to do now is find the acceleration of the 10 kilogram block in case 2. Well, what we know, being great physics students, that we know that the acceleration of the 10 kilogram block is the same as the acceleration of the 5 kilogram block. So we're going to look at this as a system. This is a whole system. So we're finding the sum of the forces of the whole system is going to equal this M1 plus your M2, times A, which is going to be equal to all the forces pointing in the direction of acceleration. So what are those forces? Let's go ahead and redraw those free body diagrams over here. We've got our normal, we've got our tension, we've got our friction, we've got our M1G, then we've got our tension again, and we've got our M2G. And over here, acceleration is going to the right, over here, acceleration is going down. So we see that starting with this block right here, we've got the m2g. It really doesn't matter what block you start with, by the way, but I always find it easier to start with the one that's like headed in the same direction first, or the first one that's going with the acceleration. But anyway, minus the t because it's going opposite of the acceleration. But then we have plus t because it's going the same direction as the acceleration. And then minus f because it's going opposite. All right, minus that frictional force. And so again, our t's cancel out, and remember our F is going to be the same as this frictional force. So the frictional force is going to equal mu mg basically. So let's rewrite this: m1 plus m2 times acceleration equals m2g minus mu m1g, because remember our friction only has to do with this 10 kilogram block, right here, M1. And so we're looking for acceleration, so we're going to divide both sides by M1 plus M2. All right, so our acceleration ends up equaling M2g minus mu M1g, all divided by M1 plus M2. Plug everything in. Our M2 is going to be that 5 times 10, which is our G, minus our 0.2 times our 10 times our 10, divided by, this time, our M1, which is 10, plus our 5. And so we multiply all this out. We're going to say 50 minus 20 gives us 30 all over 15. Ends up giving us an acceleration equaling 2 meters per second squared. All right, and we see that the accelerations are indeed different. And it's because the second case has a mass, whereas the first case does not.